continuing chapter 3 with the next type of rock. This would be metamorphic rock. Essentially, that word means changed form. So these rocks are going to be produced from pre-existing rocks such as igneous or sedimentary rock. So I mentioned that rock cycle diagram in that last chapter. You can essentially get this type of rock from any other type, but typically metamorphic rock comes from sedimentary rock that changes over time due to high pressure and temperature. Okay, now there are different degrees of metamorphism, and the next few slides are going to go into excruciating detail on the different degrees. Just essentially know that there's low grade and high grade. This is just a picture of those two types. So by low grade metamorphism, we mean at low temperature and low pressures. High grade would be strong compressional forces creating high temperatures and pressures. There is going to be a third video for chapter 3, a demonstration of something called the Hyman fire piston to demonstrate what high pressures can do to something. It won't exactly be what happens to rock, but it'll at least demonstrate that high pressures can cause a metamorphosis in something. All right, so there has to be certain settings for this to happen. So typically you have to have a rise in temperature. So normally there has to be a large body of magma nearby for this to happen. For regional metamorphism, this has to be, there again, you have to have pressures and temperatures, but these regional metamorphism usually occurs during mountain building, and we'll talk more about mountain building in another chapter. And this actually produces the greatest volume of metamorphic rock. So there are agents. So just like in chemistry, when you have a chemical reaction, there's different things that could speed up that reaction. The same thing is true for metamorphic changes in rocks. So you have to have heat. You have to have pressure, which we're defining as a stress. So you can't have a pressure without there being forces present. So sometimes there's confining pressure. So this would be if something's buried beneath other rock, the weight of all of that rock on top of it is creating a force. Its gravitational force is pushing down on a piece of rock. That's going to create a stress. And there also could be differential stress. So this is a side-to-side force that occurs during mountain building. Also, you could have chemically active fluids, and it's usually mostly water, but there are some other volatile liquids in the Earth's crust and mantle that could cause these changes. And what the fluids do, it promotes recrystallization by enhancing the ion migration. So it's just moving around parts of the rock that the pieces of it are forming ions, like we talked about in chapter 2, and then these things are attracted by charged things in the earth, and these things are able to move around in this liquid and then recrystallize. So there's just some pictures of different types of stress. So you're going to see the arrows here. On the left-hand side would be a differential stress, and then you have the arrows pointing downward. This would be a confining pressure from something above it that's very heavy. All right, there are a few textures for metamorphic rock, just like igneous rock. So we have a foliated texture. So these when minerals are lined up in a parallel alignment, and these occur when the minerals are perpendicular, which just means at a 90-degree angle to the compressional force. And then we have non-foliated texture. So these contain something called equidimensional crystals, and they resemble a coarse-grained igneous rock. All right, so this is just giving you a picture of what it means to be foliated. All right, so this is lining up in parallel to the force. All right, some common metamorphic rock. You've probably heard of slate before. You may have heard of schist. Marble you've definitely heard of. So these are all types of rock that have been formed by adding some type of compression force or high temperature. Again, just some examples of metamorphic rock. Now, metamorphic rock are basically the source of all our metallic minerals, so gold, silver, copper, mercury, lead. All of these things we use in industry are the result of metamorphosis. And the concentration of these materials are produced by other igneous processes and metamorphic processes. So these actually tend to be generated at what are called hydrothermal events. So this is an area that's really hot, so high temperatures. Basically, it's magma trying to leak its way to the surface, which basically creates very hot water and sometimes steam that permeates up through the ground. So when that steam and water permeates through the ground, it heats the area around it, and it eventually melts and metamorphosizes the rock. All right, so this is an example of pegmatites, and these are the results of crystallization in a fluid environment. So I mentioned before about when water goes into an area, it moves around ions. And this is essentially one example of what could happen when that occurs. This is a picture of a hydrothermal vent or vein. So you're going to see that you have magma trying to leak its way to the surface, so it increases the temperature around an area, which allows for a great place for metamorphosis to happen. Just some examples of resources that are created, or resources that are examples of sedimentary rock. There are some non-metallic mineral resources that occur as well. And there's two broad groups. You have building materials, so these will be limestone and gypsum, and then industrial minerals like fluorite, corundum, and sylvite. And then coal is a big one I mentioned before. I will point out in this diagram there's very few locations where you have anthracite coal, and one of those regions right here, it's the upper black region here. This is essentially the Lackawanna and Susquehanna River valleys in northeastern Pennsylvania. And about 10 minutes away from the University of Scranton is a Lackawanna coal mine, and you can actually take a tour in an anthracite coal mine. It's actually pretty interesting. So if you ever get the chance to come to Scranton and you're not from this area, one thing you should probably do is take the Lackawanna coal mine tour at McDade Park. It's actually pretty interesting. All right, just some other resources that are a result of metamorphic rock, which are essentially fossil fuels. That's why we call them that. Oil and natural gas. There's different types of oil traps, a reservoir rock and a cap rock, and some other typical oil and natural gas traps would be anticlines, fault traps, salt domes, and stratigraphic traps. And this is just a picture of the different types of oil traps and gas traps, and the different ways that you would have to construct a well in order to get at those deposits. The last slide here is a different method of extracting natural gas from metamorphic rock and sedimentary rock. And it's very controversial. It's called hydraulic fracking. If you're from Pennsylvania, you probably know what this is. Essentially what they do is, instead of digging a well that basically just taps into the resource, what they do is they drill a relatively small hole relative to the size of a well hole. And what they do is they send down different chemicals and liquids into the rock, which allows that rock to fracture and break apart. And when that fracturing happens, it releases the natural gas or whatever type of chemical that they're trying to get at. And then the only way for that chemical to be released is up through the hole that they drilled, and then they well whatever that gas is or whatever that resource is out of that same hole. What's controversial about it is that, at least in northern and northeastern Pennsylvania, is that a lot of landowners are claiming that the fracturing is causing these chemicals that they send down into the ground to cause the fracturing. They're claiming it's getting into the water table, and essentially if you have a well at your house for drinking water and house water, the water table is where you get your water from. So they're claiming that the fracturing fluid and even some of the natural gas is seeping into the water table, which is then contaminating people's drinking water. So it's very controversial topic in Pennsylvania as of right now, and I don't think the debate is correct either way. We're not really sure if it's happening or not, but people have shown their water faucets with water coming out of it, and then them taking a lighter and then actually lighting their, quote, water on fire. So if you Googled hydraulic fracking controversies, you'll probably see some of those videos.